Welcome back to geometry. Yesterday we took a look at the surface area of some of these different shapes, so pause the tape and see if you can solve these using the equations. So once we realize we're looking at the surface area, we're going to write out the equations for each of those. You should have been able to come up with equations like these guys on the bottom. We substitute in what we know, and since a cube, all 6 sides are x squared, we will simplify the equation. This might not be what you started with, but you should have been able to simplify this. In the second equation, the surface area equals, this one is 2 times length times height. This is 2 times width times length, 2 times width times height. In the third equation, the equation is going to be 2 pi r squared, that's the top and the bottom, plus 2 pi r times the height. So once we have these, each of these get to be simplified. In the first equation, we divide by 6, take the square root. In the second equation, we start cleaning things up. We have to move everything in a quadratic to one side of the equation, and my preference is factor. And in the factors, we found a negative solution and a positive solution, but lengths can only be positive, so x is 5. In the cylinder, once again, we're going to clean it up. When we move everything to one side, we notice that everything can be divided by 2 pi. That makes the equation much easier, factorable. The negative one can't be the solution, so x was 3. So now we're going to look at surface area and volume for a shape we haven't looked at yet, the sphere. The volume is actually a little bit more complex as an equation, but it's follow the equation. You guys have this equation. You are either plugging in volume or you're plugging in radius. It is a matter of number crunching. So if we take a look at a sphere that has a radius of 3, then we're going to substitute in the equation. 3 goes in for the radius, and we've got our equation written down. Same thing is going to happen if the radius is 5. 5 goes in here, and then we're ready to PEMDAS. And in PEMDAS, we need to cube first. This becomes 9. 9 times 4 divided by 3, that does simplify. And then we can also number crunch and get the approximate answer. When we have a radius of 5, the fraction isn't a nice fraction. 5 cubed is 125, times 4 divided by 3 doesn't simplify, but then once we number crunch that, we have the approximate value. Remember parentheses, before exponents, you have exponents before multiplication. Volume of a soccer ball. In this case, our radius is 4.5, so it's already a decimal. So when I simplify this one, I get 121.5 inch cubed. Remember your units, please. We can also find the volume of a shape that's made out of different parts. And it's a little bit hard to see here, but we have a hole. This is kind of like a dog food bowl. We have a hole that is half of a sphere, that's actually called a hemisphere, and that is cut into a shape that we already have here. So we want to think about the shape as different parts, and in this case we have the volume of a cylinder. We're going to subtract the volume of that half sphere or hemisphere. Then we plug in all of our numbers. So for the volume of a cylinder, pi r squared times height, and then we know we're doing half, so I put the half in here, times the formula, 2 is cubed, and then it's just a matter of number crunching these. 2 squared, 4 times 2, that's going to be 8, These two fractions multiplied together are going to give me 2/3, and 2 cubed is 8. So I can simplify these a couple ways with the approximate value of 8.38 inches cubed. That's the volume of the composite. The surface area is a slightly easier equation. It's just not divided by 3. And notice radius is squared for surface area. It's cubed for volume. So again, it's the formula, it's the units. Volume is cubed, surface area is squared. So in finding the surface areas of each of these, for problem A, we're going to set up our equation and clean it up. For problem B, what we notice is I don't have the radius, and the radius is something I need in these equations, so that means find the radius. In this case, they gave me circumference. I know circumference is 2 pi r. Plug those in. When I divide those by both the 2 and the pi, I come up with 6. Once I have the radius, I go into the equation for surface area, plugging in a 6, and number crunching that. 452.4. Make sure you use your units, feet squared for surface area. Now they can give me other things that I'm looking for. I don't have diameter in the equation for surface area. Doesn't matter. I have surface area, and I can use that to come up with a radius, and then I'll figure out diameter. So when I plug those in, first step is going to be I'm going to have to get rid of the 4 and the pi. Don't multiply by pi, 3.14, get an approximate. You're just going to keep track of a lot more decimals. When I divide these guys by 4 pi, pi cancels here and here. So really, what I'm really doing is 20.25 divided by 4. When I do that, I get this, and I'm going to keep all the decimals here and just go square root of my answer, because that way I'll get a more exact answer. So square root of both sides, square root of this with all the decimals. In our calculators, remember that's second squared, second ANS. And although there are positives and negatives as answers, the negative doesn't make sense. This is a length. So positive 2.25. Once I have that, now I know the diameter is 2 times the radius. Plug that in and learn how to type. Okay, there's a couple other examples where we don't have the radius to plug into the equation just yet. So we might have to use an equation that's a little bit ahead of that to come up with the radius, and then I can plug it into surface area equations. This is all pick the equation, solve something, do the next step. They're all about equations. If you have the equations down, these are plug them in, number crunch them. In the first one, I have the diameter, not the radius, so find the radius. D equals 2r, the radius is 20. Now I'm ready to plug that into the equation. Remember, 20 gets squared first before the multiplication. So I get 1,600 pi feet squared, or 5,026.5 feet squared. In the second equation, they gave me circumference. Well, I know an equation for circumference and radius. It's C equals 2 pi r. Plug it in. Remember, you're going to divide by 2 pi. That gives me a radius of 3. Once I have the radius, plug it into surface area. Do the number crunching. 113.1 feet squared. I can always, if I have surface area and I have an equation for it, I can find something else. You just have to remember to plug in surface area for surface area. So it goes in over here, and then this is going to be number crunch. First thing to get rid of, 4 pi. So I'm dividing both sides by 4 pi. Pi cancels. 30 divided by 4, 7.5. Then I'm going to take the square root of both sides, and that's going to give me approximately 2.74. My units on this are meters. Radius is a single length, meters. They can give me the equation in words. I've got the volume of I've got the surface area. What I want is volume. You're just going to take it in steps. The first equation deals with what I have, which is surface area. So I take the equation, I plug in what I know, where it belongs, then I'm going to number crunch that. Divide by 4 pi, that's going to be 144. Square root of that is 12. Once I have the radius, now I can go back to the volume equation. And in the volume equation, radius is 12. Plug it in. 12 cubed is my first step. Then times 4 divided by 3. Last step times pi. 7,238. Volume is cubed. Here's another example of a composite. Remember, sometimes composites are addition. In this one, we're going to do the volume of the cone, that is the bottom of the ice cream cone. And I have half a circle, half a sphere, that's a hemisphere. Then the equations for each of these. The volume of the cone, pi, r is 1 squared times the height, 5. 1/2 of the equation, plugging in radius is 1. Once I have that, I'm going to number crunch these things. These two fractions multiply to 2/3. 1 cubed is 1, 1 squared is 1. So we end up getting this, and the volume is 17.8 meters cubed. One last example. When we have one thing and we're looking for not necessarily the radius, but we have to find the radius in order to find the other part, the volume. I can go either way on these guys. I've got surface area, plug it in, number crunch this, dividing both sides by 4 pi. Square root of 81 is 9. Once I have that, I can go back to the volume equation. It's pick the equation. Plug in what I know, number crunch it, and we have a volume of 3,053.6 centimeters cubed. Okay, those are the types of equations that we're going to do today. If you have any questions from your homework on Google Classroom, please make sure you PM me, let me know. Have a good day.